So when we write function notation and it's f of x, or it's the p of n, really the number inside the brackets corresponds to the independent variable x. If it's p of n, our independent variable is n. Keep in mind that when we draw on the Cartesian plane, the independent variable is always on the horizontal. My value, my function, generally takes on the y value. So keeping that in mind, given example 9, given the graph of the function f of x, find p of -1. Sorry, f of -1. So the input is -1, or our x is -1. What is the value of our function? Here. There's where x is -1. The value of this function, or the y value, is 0. Now the f of 4. So I have to look where x is 4. So if I look where x is 4, that's 1, 2, 3, 4. So this is where x is 4, and I go down to my function, and I see that my y value of my function is -2. Similarly, for f of 7, my y value will be 1. On the other hand, when we look at D, if you notice, your input is not defined. And f of x is equal to -4. Well, this really asks the question, when y is -4, what is the x value? Well, the x value when y is -4, I believe, is -3. When f of x is equal to 1, what I notice is that there's two x values. One and 7. Last example, example 10. So given the graph of the function v of t, find. So I know, you know from science that v of t graphs are velocity time graphs. So if I look here, in the bracket is 1. So really this means my time, or my t, is 1. The value of v, on the other hand, is 0.2. When t is 5, the value of v, my y value typically, is 0. When v is 10, when t is 10, v of t is 0.2. Now, what is the value of t when v of t is 0.2? Now, keep in mind, v of t, I write it as, it might make more sense when you say v is equal to 0.2, negative 0.2. That might make more sense to some of you. And I'm able to see that, well, that happens when it should be t is equal to 3. Well, v of t is 0.4. So when is the velocity 0.4? And I take a look at my graph, and 0.4 is up here. When is the velocity 0.4? I would call this undefined, or does not exist. It just doesn't happen.